breaking the wall of future cities. How technology shapes the urban landscape of tomorrow. Carlo Ratti, Massachusetts Institute of Technology.
On November 9th, 1989, I was in my teenage room, watching a wall become a bridge.
All right. Good afternoon, everybody. Great pleasure to be back in beautiful Berlin. What I want to share with you is some of the work, some of the research we're doing at MIT at Senseable City Lab. Also with cities around the world. We found that in order to do research that then can be turned into action, it's really important to be close to cities and close to citizens. Why are we passionate about cities? If you need to remember 4 numbers about cities, just remember those. 2, 55, 75, and 80. Cities are only 2% of the surface of the planet, but are 55% of the population, 75% of energy consumption, 80% of CO2 emissions. So if we can do something to make our cities a little bit more sustainable, that can be a big deal. And today there's an interesting situation. The situation is that digital and physical are converging in cities. We get a lot of data, and the data can help us to better understand to change the way we understand, design, and live in cities. So, for instance, we can look at cities like this, like living organisms. And then, that changes the way we understand not only the physical city, but the life that unfolds inside it. And we've been doing it at MIT for some time. We've been discovering a few things. For instance, this is a very interesting book by a great mathematician, Zip. And in this book, Zip discovered, among other things, that if you got 2 cities, the flows between 2 cities are similar to the gravity law. So if you take Berlin and if you take Hamburg, then the population flows, for instance, between Berlin and Hamburg can be described as population 1, population 2 divided by distance squared. Now, at the time, that's what you could do, like 100 years ago, but today with new data, you can look at new dimensions of this. So we discovered that also there's another component there that's related not only to distance, but to frequency, and how many times you go. So the invariant, if you want, is RF, not only R, the distance between the 2 cities. Or something else is we could finally figure out recently is something that bothered me since I was a student there. That's Cambridge, England, and that is Darwin College. And I realized something puzzling, that I was going from my college, Darwin College, to the department, following one route, but then going from the department to the college, following a different one. And why was that puzzling? Because the shortest path, as we all know, is symmetrical. A to B equal B to A. So you could say it was consistently inconsistent. And for somebody studying and doing rational studies, that was really puzzling. Well, again, with the data we have now in cities, we started looking at a lot of anonymized traces in Boston and in San Francisco. And we realized that actually our brain works in a way that's very similar to many animals and does not shortest path, but vector-based navigation. Vector-based means that you are looking at a vector at the objective and minimize angular deviation as you're moving towards it. And if you look at that, that is close to shortest path, as you see here, but not exactly the shortest path. And you can imagine that like tens of thousands of years ago in the savannah or in the Cerrado in Brazil, our ancestors were trying to get to the destination as best as you can. The vector-based navigation is super efficient from a computational point of view, but save against some computational power for other things, for looking around, for looking at problems, and so on. So somehow it's an interesting evolutionary trade-off between being perfectly optimal with shortest path and also keeping some computational power for something else. Those are the things we've been doing at MIT, and I will not tell you more about some of those projects. I want to tell you tonight about something we started looking at recently, and that has to do with how we look at the city. Looking at the city has been an activity that has been happening for a long time. This person, who knows who this person is? Camillo Sitte. Camillo Sitte at the end of the 19th century, 1889, he wrote a beautiful book that's still studied by every architecture student called the Städtebau. And what he did was actually go around many cities, especially in Europe, analyze them, look at the configuration, and really, at the time, look at the visible city and how it affects what we like, what we don't like, and how we behave inside it. 100 years later, less than 100 years later, in the 1960s, this other guy called Kevin Lynch, who was at MIT, tried to develop that further. An incredible book called The Image of the City. And again, how the city looks says a lot about how we understand it and how we move inside it. What he says at the beginning is this book is about the look of cities and whether this look is of any importance and whether it can be changed. And then, he looked at different things, 5 main parameters. You see them here. Here you see different resolutions of the city. And so what Kevin Lynch was looking at was, for instance, about what you see here, about paths, about nodes, about districts, about edges, and also about landmarks. So this is just to say that there's a long history of looking at cities and trying to make sense of them. And then we come to this guy in the 1970s or 80s called William White. And William White, in this beautiful book, summarized some of his findings. What he did for the first time was actually looking at video from cities. He went into New York and he started taking video. It was the very beginning, so those were Super 8 cameras. And then he looked at all the video and then started analyzing. Look at this, by the way, William White, if you've been in New York and enjoying the beautiful Bryant Park, say thank you, William White, because he helped preserve it and save it for today. And he took all this video. This is Bryant Park, how people move in space. He looked at what facilitates connections, interactions, new friendships, people you don't like. He also discovered some beautiful, simple things like, what attracts people, it appears, he says, is other people. And also how things change in the course of the day when it's hotter, warmer, and so on. And then he was actually looking at this and annotating all this and actually turning that into quantifiable thing. Here he counts all the people and how they're moving. You see it here, for instance, if you take the camera. That's again New York. He was looking at a lot of squares and sidewalks. And then from this, you see at the moment you can go into counting and looking at how everybody's using space. Now, when he does it in the late 70s, early 80s, he's saying in one of the notes, this is taking video is fun, it's enjoyable, but actually the difficult part is how to analyze it. Evaluation is the problem, he says. And well, today, we can actually do evaluation very fast, using deep learning, CNNs, classify something to understand and recognize things. This is what can be done since a few years in a very precise way. You classify different things on images, on video, and then you can also trace them in space. And so we decided, we asked a question a few months ago, which was, how has public space changed? And so we looked at the footage of where William White used to take footage, like 50 years ago. We looked at more recent footage, taken 10 years ago by a colleague, a sociologist, and we started comparing the two. And we discovered something that we didn't expect. That's a paper, if anybody's interested in looking at it, it came out just very recently. And then if you look at lingering, between 1980s and 2010, we don't linger anymore, or much less, in public space. I think because we got phones and so on, it looks like we spend much time. We define here lingering, people moving at less than 0.5 meters per second. So when you're going there and enjoying the space. Walking speed is faster. We walk 15% faster today. And you see it here, by the way, here you see all the different places that he analyzed, and you see to the right all the analysis of all of this. And solo walkers are more or less the same. People who are solo in public space, 67% 50 years ago, 68% today, but with a big difference that we then don't meet. If you look at that, those are people, solo people who then meet somebody else, and that's a percentage, and that's how many seconds before you enter a certain space. And you see that actually public space is not anymore the place that brings us together. So this is just an initial piece of research, but then we're asking, is something fundamental changing in the way we use public space? And public space is so important. Cities didn't exist once upon a time. Cities emerged around 10,000 years ago when our ancestors found a beautiful way to bring us together so that together we can exchange goods, we can exchange ideas, like today, we can exchange chromosomes. So a beautiful way to make sure that together we are more than each of us individually. And the key thing of the city, the glue of the city, since the beginning has been public space, the Agora in Athens, the place where we go. And I would say that public space is especially important today, because in digital space, it's so easy. You can cancel all the people you don't like, all the people who think in a different way from you. But actually, public space has an incredible dimension that's inevitability. You need to face diversity. You meet people with different political ideas, with different people you normally are not part of your inner circle online. And so I think today is kind of an antidote against the polarization we are seeing everywhere. And so this question is what we want now to explore more. It's just the beginning. We think with AI we can start to look at some of those dimensions that people were looking at, like William White 50 years ago, and see how really this glue of the city, this is a paper not a paper, just an op-ed I did in The Guardian, if you're interested, but basically how this can help us to see in the future how public space can remain what it is, the place of encounter, and the place where together we are more than each of us individually. Thank you.